So this is a supplementary math lesson for Algebra 1 on lesson 79 in your textbook, consecutive integers. Okay, so this is a favorite type of word problem for Mr. Saxon, who wrote your curriculum. He loves these problems. They're going to be with you a very long time. They'll be with you all the way through Algebra 2. They'll follow you into advanced math if you go into that class, and we went through probably a quarter of the year before they finally dropped out of advanced math, and even at that, occasionally one resurfaces in homeworks or on a test. So Mr. Saxon really liked these type of word problems, so the point is you need to learn how to do them. They're going to be around a long time. They're not going away anytime soon, okay? So basically, what we're looking for in the answer is, it's a word problem, excuse me, and the answer to it is going to be 3 consecutive integers. And of course, if we look at our number line, okay, consecutive integers are numbers that are right next to each other, okay? So we're going to be solving for a group of consecutive integers. It might be 3, might be 4, might be 5 in a row. We don't know, okay? The problem is that right now, we don't know where they are on the number line. And if we recall from algebra, the basics, if we have one unknown, we need one equation. If we have 2 unknowns, we need 2 equations. If we have 3 unknowns, we need 3 equations to solve. So it would appear that with a problem that says, for example, in lesson 79 in your textbook, 79.1, and I'm going to be referencing that as well. If you might want to turn to that in your textbooks. If that's the case, go ahead and pause the video and get to page 284 in your textbooks, lesson 79. So example 79.1 says find 3 consecutive integers such that the sum of the first and the third is 146. Okay, so it would appear we have 3 unknowns, 3 integers. We would need 3 equations. Okay, but it's helpful to know we can express, excuse me, once again, all of those integers in terms of the first one. And so here's just an example. If, and I'm just saying, if the solution to our problem is the 3 consecutive integers end up being 1, 2, and 3 on the number line, okay, we will designate the variable where we don't know of the first as n. N will represent, like in our normal algebra equations, the variable x is the unknown, okay? This time it's n. Well, the second one then will be n plus 1, and the third one will be n plus 2, okay? So all of the variables, the 3 unknowns, are expressed in terms of the first. So if we can determine what the first number is, we will be able to determine all 3 of them. So we actually only need 1 equation, okay? So then the tricky part of these problems is deciphering what it says in the word problem and putting it in equation form, okay? Let's go to example 79.1. Find 3 consecutive integers, and we're going to represent them as n, n plus 1, and n plus 2, because we don't know where they are along the number line, such that the sum of the first and the third is 146. Well, so we have a sum, an addition, of the first. The first is represented as n, okay? And the third is represented as n plus 2, okay? I'm going to put that in parentheses. It's kind of a good practice to start doing that right now. And it says the sum is, and every time we see that word is, it's in an equal sign, 146. Okay? So that is the setup for the equation. Now we notice there's nothing to do inside the parentheses, so we can get rid of that. We can say n plus 2 will equal 146. Okay, and now once we have the equation set up, you'll see the actual algebra is really simple, to go ahead and do it. It's the same what we did. We combine all the variables on this side, 2n. We bring all the numbers to the other side. Okay, it'll be 144. Okay, we divide by 2, n will equal 72. Okay, let me move that down a little bit so you can see that 72 a little better. Okay, so n is 72. Now that is not our answer. They're asking what are the three integers, the three consecutive integers. N is just the first one. Okay, so the answer will be 72 is the first one, n plus 1 is 73 is the second one, n plus 2 74, whoops, 74 is the third one. That is the answer for that. Those are the three consecutive integers. Okay, so the two things to remember: we're going to express the three integers in terms of the first one in the series. We solve for that first one, then we go ahead and determine what the three integers are. The second, more tricky part of the problem is actually deciphering and setting up the equation. This one was rather easy. Let's go to 79.2 on page 285 of your textbook. And it doesn't matter, as you see. I said if it was 1, 2, 3, that would be our variables. They ended up being 72, 73, 74. N and n plus 1 and n plus 2, we're going to keep the same expression because that will be valid anywhere along the number line. We just have to determine what is that first integer, what is the n, where does it start, okay? Now, example 79.2, it says find three consecutive integers such that twice the sum of the first is 2 less than 3 times the third. Okay, now this is where the wording gets a little tricky. Now, you will have an advantage over Algebra 1 and Advanced Math so far because we've gone over a number of these. So I've kind of figured out a way to maybe teach it to understand it a little bit better using those guys as guinea pigs. But anyway, let's go into this example. So it says find three consecutive integers, so we're still going to use n plus 1, n plus 2 as those integers, such that twice the sum, okay, so we're going to have 2 times the sum. So I'm going to put that sum inside of parentheses. Something is being added, and we're going to multiply 2 by it, such that twice the sum of the first two, okay, the first two integers, so the first two are n, and the second one is n plus 1. That is the second one. The sum of the first two, twice the sum of the first two, is 2 less than 3 times the third. Now, we don't have any equality, we have a less than statement. And I recommend you go ahead and write it as it's written, okay, is 2 less than. So I'm going to put a less than symbol, and I'm going to park that number 2 up on top just so I know it's 2 less than. And then what is it less than? It's less than 3 times the third integer. The third one is n plus 2. Okay. Now that I've had it set up in a basic form, I'm going to go ahead and then address this less than symbol. Okay. So what is it saying? It's saying right now, as I've written it, this side is 2 less than this side. Okay. 2 less. So how do I make those equal? Well, you have 2 options. You can do it this way. You can either add 2 to this side, since it's less on this side. If we add 2, they'll be equal. Or you can subtract 2 on this side. This side is greater, so if we subtract 2, the sides will be equal. Okay. The book decides, and I like to do this as well, is adding 2 because I don't like to introduce negatives if I can avoid it. Okay. So the expression is going to be 2 times n, and again, there's nothing to do inside the parentheses, so let's get rid of that additional parentheses inside there. Okay, it becomes n plus 1, and then I'm going to add 2. I'm sending the 2 over to this side, okay, because it's less than. I'm adding 2. Now it is equal, and then I can do the distributive here and multiply this out. It becomes 3n plus 6, okay. I can, in the parentheses, I can combine the n's. I get 2 times 2n plus 1 plus 2 equals 3n plus 6. Okay? Then I can do the distributive property here. 4n plus 2 equals 3n plus 6. Okay? Now, as you see, let me adjust that screen down so you can see that last line. Sorry about that. As you see now, the algebra involved is rather simple. We're just going to combine the n's over on the left-hand side. That's the variable, the unknown. We're going to combine all the numbers on the right-hand side and then solve for n. Okay. So once we've solved for n, we go back up here. Okay. The book goes through the math here. It finds that n equals 2 for this problem. Okay. So that's not our answer. Our answer is, well, n is the first number, it's 2. The next number is 3. The next number is 4. That is the answer, because they wanted 3 consecutive integers that fulfilled this rather wordy expression of mathematically what they wanted to accomplish. Okay, so the trick is deciphering this first equation in the proper way. The expressions are always going to be the same for consecutive integers. They'll be n plus 1, n plus 2. If they want 4 consecutive integers, the next one would be, right, n plus 3. Okay? And then the math, the algebra, is actually rather simple. The tricky part is setting up this original equation. Okay? And again, if it's a less than or greater than expression in the word problem, go ahead and put in the less than or greater than symbol. Park the number above it for right now. We're just going to set it aside for the moment so we can continue writing our equation. Then we'll go back and change the equation into an equality. Which side do we want to send that number to make the sides equal? So I hope that helps. We'll have lots of these in the future. So like I said, try to get a good grasp on what's going on with these problems. So hope that helps. Have a good weekend and see you later.